The purpose of the flyweight pattern is to lower our memory footprint and help us deal with performance issues. The idea is that our application may create a lot of objects that are of the same type and need multiple instances of that object. And we don't want to recreate all of those multiple instances if we don't have to. We would much prefer just to pass around references of that given instance. So in this demonstration, we have a user class, and our application is going to have a lot of users, and the application is going to use the user object, so it'll actually have a whole lot of copies of any given user in the application, and that's going to cause us some issues with memory. Our user object is fairly simple. It has a first name, last name, user ID, and username. No problems there, but it also has a followers list, which contains a list of other users. So that's going to get a little bit heavy. So if we have copy after copy of this, we could have some memory issues, not to mention that if this user comes out of the database, every time we create it, we're actually going to be querying the database. So we'll create some more database traffic that we don't necessarily want either. Our user factory is what's going to help us work with that problem. And the user factory has a dictionary of users and, just for demonstration purposes, a users count. And that'll tell us how many users are actually in the users dictionary. And that has a single method that the application uses called getUser. So here's our user class. And again, it's pretty basic in that it has a user ID, username, first name, and last name, and then that nasty list of followers. It also has a static class for getting a user. And this is just used to get a user out of a database by passing in the user ID. And for our demo, we're just going to create a new user with a new unique identifier. And here's our user factory, and this is really the key to the flyweight pattern. We have a dictionary with a key of type GUID, which is the user ID, and then we're going to store the users in the values. And we'll new up that dictionary. But note, we're at construction. We're not loading it up from the database for all the users at this time. It's an empty dictionary when we start. The user factory has a single method called getUser, and it's going to take a GUID parameter for the user ID. So the application is going to use this method to get a user object instead of creating the user object or asking for the user object directly. We'll go into the dictionary and we'll see if it contains the key for the user ID that was passed in. If it does, we'll just go into the users dictionary and return that user that corresponds to that user ID. So we won't create a new object. We'll be passing around a shared instance. If the user is not in the dictionary, then we'll turn around and we'll call getUser on the user object and pass in the user ID. And you remember that getUser probably pulls the user from the database. We'll take that new user object and we'll add it to our dictionary, using, of course, its user ID as the key. We'll increment our users count, and then we'll return that user object. So the gist of this is that we won't actually create or pull from the database a user object until it's actually being used, and it's not being used until this getUser method is called. Also, if we're looking for that same user object in another area of code, we don't recreate the object. We don't do another database call to get that object. We just go into our dictionary, check to see if we have that key, and then return that user. So we're passing around a reference of that user object as opposed to requerying the database or recreating a new user. So we're keeping our memory footprint as small as we can, and we're also not creating users that we're not using. We only create the user when we actually need it. So in that way, we're attempting to minimize the amount of queries to the database, and we're trying to minimize our memory footprint as well. Now, the side effect of that, of course, is twofold. One, we're passing around a reference to the user. So if anywhere we're passing the user object to makes a change to that user object, the user object is shared throughout the application, so that change is migrated throughout the application as well. That may actually be a good thing, but it may be something that you necessarily want to be aware of as well. The other thing is that because we're not requerying the object, if there were changes that were made to the object outside of this shared user, and we're not requerying the database, so the underlying database object is changed, but we didn't do the requery, so we don't actually have those changes in this dictionary. So there may be a little bit of age to this as well. So these are just a couple of issues to think about. So there's not a whole lot to visually demonstrate here. This is the user factory, which is going to be our key to our flyweight pattern. And all it does is create user objects for us and pass out references where it has them. And that's really the whole point of the flyweight.